Hey everybody. Alright, so today's lesson is section 132. We're going to basically just add on to what we've been talking about with simplifying radicals and converting from what you see in front of you into a radical. We're also going to add on to simplifying I. So I actually thought we would go over these problems in the homework real quick so that we can have a better understanding for what we're going to do today. So just give me a minute to kind of re-explain what you guys did yesterday. Yesterday you guys talked about how to simplify I, and the biggest thing that we talked about was the fact that I squared gives you -1. So we don't need to memorize what I squared, and what I to the third, and I to the fourth, and I to the fifth, and so on and so forth are. Really the only thing that we need to know is what I squared is. If we know what I squared is, we can make everything look like I squared by using the power of exponents. Okay, so let me explain. So if you have I to the 44th power, I can rewrite that as I squared to the 22nd power. Okay, because remember, when you have exponents, 2 times 22 is what gives you 44. So this, what I just wrote, is the exact same as this. But I can evaluate it now because I squared is -1 raised to the 22nd power. And if I have -1 times -1 times -1, 22 times, all the negatives are going to end up canceling out to just give me 1. So that means that I to the 44th power is the same thing as 1. Okay? Let's try with this one. I to the 70th. So I want to start by saying I know what I squared is, so everything in terms of I squared, and then I can raise this to the 35th power, because 2 times 35 is 70. So I wrote it as I squared because I know it's -1 raised to the 35th power. So if I multiply -1 by itself 35 times, everything's going to end up pairing up, canceling out, but I'm going to be left with a -1. Okay? Alright, and then let me try one more. So if you had a problem like, um, oops, sorry. Let's do a problem like number 16. So I'd start by saying I squared, and I'm trying to get as close to 103 as possible without going over 103. Okay, so I can do 51, because 51 times 2 is 102, but that leaves me with one extra I. Okay, so I have to be very careful that I'm still coming up with the same value of I to the 103rd power. 2 times 51 is what gives me 102, times another I is what gives me 103. So now it's the exact same as what I started with. I again say that I squared is -1 raised to the 51st times I. Okay, well this, -1 to the 51st power, because it's odd, is going to end up having an extra negative left over, times I. Okay, so this is what I get. So -1 times I is just -I. Okay, remember there's 4 possibilities. You're either going to get a 1, a -1, an I, or a -I, depending on what your exponent is. Okay, so now, today, you're going to add and subtract complex numbers, just like we've been doing, but we're going to add on to it a little bit. So why don't you guys do the warm-up before we get to the lesson? Why don't you pause the video, try the warm-up, unpause it, and then you can look at the answers, and I'll walk through it pretty quick. Okay, so when you set up your problem, length times width, this is what you get. Remember, you need to be putting parentheses around this and saying millimeters squared. A lot of you guys are forgetting the parentheses. Write in standard form. Be very careful that this is what gives you 2x to the third, not squared. Okay? Over here, the perimeter of a rectangle is 26x squared plus 8x plus 12. I saw a lot of good work with this problem. So we're saying that this is the perimeter, which is equal to 2 of these plus 2 of something else. Okay, I'm going to distribute to get 10x squared minus 2x plus 18 plus 2 of something. Okay, I'm going to bring this down. Alright, now remember, I want to get this over here by itself, so I have to get rid of all 3 of these terms. So I need to subtract 10x squared, I need to add 2x, and I need to subtract 18. Make sure you're doing the opposite to get rid of them. So 26x squared minus 10x squared is 16x squared. 8x plus 2x is 10x. And 12 minus 18 is negative 6. And that's equal to 2 times something. So I don't need this whole thing. I need to divide this by 2, which gives me 8x squared plus 5x minus 3. And that whole thing is my other dimension. So it's not squared or cubed, it's just kilometers. Again, make sure you put parentheses. Okay? Alright. So let's go into simplifying. Some of these are going to be pretty quick and not really need much work, but others are going to take a little bit more space. So the first one, just like when we add terms that have variables raised to the same power, we're looking for the same thing here. So I'm adding 6 and 8 gives me 14, positive 5 and negative 3, so those are my two i's. Notice I'm adding, I'm not multiplying. So 5 plus negative 3 is what gives me 2i. Make sure we're always writing things in a plus bi. That is our standard form. Real plus imaginary. Okay? Alright, next one we're subtracting. So when I distribute, I get negative 11 minus 10i. And then this comes down. So 12 plus 4i. So I have these four terms. My real is negative 12 and negative 11, which makes negative 23. My imaginaries, I have 4 and I have negative 10, so I have minus 6i. Real plus imaginary. Okay. Next one. I have 5 plus negative 5, so those end up canceling. I have negative I plus 12i, which just leaves me with 11i. Okay. Next one, I need to distribute before I can combine like terms. So this gives me 14i plus 16 minus 14i. Well, 14i minus 14i cancels and just leaves me with a real number of 16. Okay. Next one. I could go through and I could do this times this and this times this and this times this and this times this. However, if I take a second to look at what I'm given before I start the problem, I can see right here that I have negative 8i squared. And negative 8i squared, we know what I squared is. It's negative 1. So this is really just saying negative 8 times negative 1, which equals positive 8. So this whole part right here is actually just saying positive 8 minus 3 times 5i to the 42nd minus 7. So my problem actually becomes a lot quicker because I recognize that I squared. 8 minus 3 is 5 times 5i to the 42nd minus 7. So now I can just distribute that binomial. And I want to do this before simplifying my other I. So 5 times 5 is 25. I to the 42nd minus 35. So I to the 42nd is what I need to now simplify. So I to the 42nd is equal to I squared, like we did yesterday. And if I multiply by 21, I get 42. So I squared is negative 1, and I'm raising it to an odd power. So if I do that, I'm going to end up getting all my negatives canceling with one extra negative, so I get negative 1. So this is actually saying 25 times negative 1 minus 35. Well, 25 times negative 1 is negative 25 minus 35. Gives me a negative 60. So I get a real answer. Okay? Alright, let's try the next one. So in the next one, I'm adding. I need to make sure I'm adding and I don't all of a sudden multiply. I to the 20th and negative 4i to the 18th, unfortunately, are not like terms, so I cannot combine them. I can't simplify them like I did in the last one. So I'm going to start by combining my reals. So I have 12 and negative 18. That makes negative 6. And then I have minus I to the 20th and minus 4i to the 18th. So I'm going to do a little bit of side work to figure these problems out. So I to the 20th is equal to I squared times raised to the 10th and this means I have negative 1 raised to the 10th power. So negative 1 to an even power means I get 1. So I know that this is negative 6 minus 1. So I'm replacing this right here with 1. Minus 4 times, and now I need to figure out what I to the 18th is. So I to the 18th is equal to I squared raised to the 9th power, which means it's negative 1 raised to the 9th. Negative 1 raised to an odd power means I'm going to end up having a negative left over, so I get negative 1. I get that. So order of operations, I have negative 6 minus 1, negative 4 times negative 1 is plus 4. So negative 6 minus 1 is negative 7, plus 4 gives me negative 3 is my final answer. Okay? Hopefully the last two problems weren't too bad. It all comes back to how well you did with yesterday's material. So let's flip it over. So number 9, I'm subtracting. Okay? So because I'm subtracting, I notice that my i's are to the 9th and the 15th, so I don't see any I squareds. So I'm going to start by saying 5 plus 6i to the 9th minus 5 plus 3i to the 15th. So I distributed the negative. Okay, well, 5 and negative 5 cancel, so all I need to do now is figure out these powers. So I'm going to say 6 times, and I'm going to do a little side work. So I to the 9th is equal to I squared raised to the 4th. Now that's only 8. I have to add another one to make it to the 9th. And now I have 9 of them. Well, this is negative 1 raised to the 4th times I. So negative 1 to the 4th power is 1 times I, just gives me I. So instead of it being 6 times I to the 9, it's just 6 times I. And then plus 3 times, and now I need to figure out what I to the 15th is. So I to the 15th is I squared raised to the 7th, because that's 14, but then I have an extra left over to make it 15. So I squared is negative 1 raised to the 7th times I. So negative 1 to the 7th is an odd number, so that means I'm going to have a negative 1 left over times I, which leaves me with negative. So this one is negative I. Alright, so this gives me 6i minus 3i. 6i minus 3i is a total of 3i. So that's my answer. Alright, let's try it again. Alright, I have I to the 5th and I to the 23rd, both of which cannot be simplified, so I'm going to have to do, I'll do that last. So I have 5 and 10, which gives me 15 minus 2i to the 5th plus I to the 23rd. So I'm going to have to do some side work again. So I get I to the 5th, which is I squared raised to the 2nd. Now that only gives me 4, which means I have to add another one. Okay, so I squared is negative 1 raised to the 2nd times I. Negative 1 squared is 1 times I. This gives me I. So this would be 15 minus 2 times I plus, and I need to figure out what this is. So I to the 23rd is I squared raised to the 11th power. That's 22, plus an extra one makes it 23. So I now have I squared to the 11th times I. That's a total of 23 i's. I have negative 1 raised to the 11th times I. So negative 1 raised to the 11th, that's an odd power, so I'm going to end up getting negative 1 out of that, times I, which means I have negative I. So negative I. Alright, so this means I have 15 minus 2i minus I, which means I have 15 minus a total of 3 i's. And there's my answer. Okay? Okay, at this point, you should be able to do the next couple on your own, so why don't you try 11, try 12, and then you can unpause the video and listen to me go through them, but try them on your own first to see if you're kind of getting a handle on this. Okay, so here's what I see. I see negative 8 minus I squared plus 11, or I to the 11. So I see 3 terms, but this right here I can simplify right away as negative 8 minus, be careful with the fact that that's a minus sign though, because it's minus a negative 1. Okay, maybe it'll help actually do this. So it's minus, and then this I squared is what I need to replace with negative 1. So it's negative 8 comes down, the minus sign comes down, and then I squared gets replaced with that negative 1. Okay, and then plus, and then the I to the 11th I'm going to do a little bit of side work on. So that's the same as I to the 2nd raised to the 5th. There's your 10, and then another one makes it 11. So that makes it negative 1 raised to the 5th times I. Negative 1 raised to the 5th, because that's odd. It means I'm going to have a negative left over. So that means that this is negative 1 times I, which is negative I. So that means it's plus a negative I. Okay? So negative 8 minus negative 1 just means I have negative 8 plus 1 minus I. So combine negative 8 and 1 to get negative 7 minus I. Okay? Alright, if you haven't already done 12, again, try number 12 before you watch me do it. See if you can do it on yourself and check yourself. 2 days ago, we talked about how to simplify radicals, and right here, we should see that that's a perfect square, but it's negative. Remember, we can't take the square root of a negative number, not in the reals at least. So what we do is we take it out. The square root of 49 is 7, but because we can't take the square root of a negative, it's an imaginary 7, so 7i. Remember, when you take it out, you have to multiply. So 9 times 7 gives me 63i plus 10 times, and I need to figure out what 51 is, or I to the 51st. So that would be I squared times 25, so that's 50, with another I. So I squared is negative 1 raised to the 25th times I. So negative 1 raised to the 25th, since it's an odd, negative 1 raised to the 25th is going to be negative 1 times I, which is negative I. Okay, so then I'm going to replace this right here with negative I. Okay, so this means I have 63i minus 10i, which leaves me with 53i. Okay, so we just combined what we did 2 days ago with simplifying radicals and getting imaginary with simplifying I. Whew. Alright, next problem. Alright, last problem. The impedance of an element can be represented using the complex number V plus II, where V is the element's voltage and I is the element's current. If two elements are used in a current in a series, the total impedance is the sum of the impedance of each element. So, sum. The total impedance of the circuit is the sum of the impedance of elements 1 and 2. So, sum of elements 1 and 2. So, you're adding elements 1 and 2. Element 1 has a voltage of 25 volts and a current of 1 milliampere. So all of this is saying, it's a lot of words, but all it's saying is your voltage is real, so that's your 25. This is imaginary, so it's just plus 1i or I. Element 2, adding this element plus this element. Element 2 has a voltage of 20, so that's your real number, plus a current of 1.5, so that's your imaginary. And all you have to do is to find your total impedance, you find the sum of them. So 25 plus 20 is 45, and I plus 1.5i is plus 2.5i. And that's it. Okay? Your homework is going to be worksheet number 9. It's going to look like this. It's going to have some simplifying on there. Right, adding, subtracting, you're going to have to simplify some i's like you did yesterday. You're going to have to do that with radicals, some more simplifying, and then a little bit of review from what you guys have been doing. Okay? Just remember that as you guys go through here, you're going to probably have to do some side work as like this, like how are you going to simplify I to the 32nd over here. You really do one like this, so before you grab your homework, let me actually show you this. Remember that you're still keeping your rules of distributing and your rules of I. So like negative 20 times 2 is what gives you negative 40. I squared times I to the 17th, remember you add, so to the second and to the 17th means you're up to the 19th. Negative 20 times negative 13 is a positive 260, and then you have to bring the I squared with it. Okay, and then negative 25 times 2 is what gives you negative 50i to the 17th, and then this gives you positive 325. Now, let me call your attention to something. So let's say you did all that. That's a lot of work and a lot of things I have to simplify because I have to simplify this, this, and this. It's 3 different i's. However, this is like the problem that we actually did in the notes. If you pay attention and catch the fact that this is negative 20i squared, you actually don't end up having to do that because that's negative 20 times negative 1, which means that that number right there is actually 20 minus 25. Okay, so pay attention to those things as you go through. Don't just start a problem. Look at really what's happening. Am I adding? Am I subtracting? Am I multiplying? Is there anything I can do first before I start the problem? Okay. So go get you can show the sub that the notes are done, and your sub will give you number 9 worksheet. You should be working on it in class, no phones, no Chromebooks, but when you are done and you're at home or on your own time, then check the Google Drive. Okay? If you have any questions, I'll be back tomorrow, so will Miss Fitzharris. So if you have any questions, go to the math resource before school, go during the day, but get your questions answered. Friday's lesson is going to be more of this, but a little bit harder. Okay, so if you're having trouble simplifying I, or adding and subtracting and simplifying I, make sure you get those questions addressed before coming to class. We may not have time to answer questions. All right, see you guys Friday.